Okay, so we are moving on to relations and functions this chapter. So the first thing we're going to talk about is relations and functions. Relation is a set of ordered pairs. A function is a relation in which each input has exactly one output. Okay, so the domain of a function is the set of its inputs. And domain is always looking at the x values. Then the other thing I have is my range of a function. This is my set of outputs. And then range always has to do with my y values. Okay, so looking at this table of values, my x's are my inputs, and my y's are my outputs. So x is what I plug in, y is what I get out. Then I need to give my domain of the function. So what I'm going to do is I'm going to put it inside of curly brackets, and then I'm going to write all of my x values, and I typically want to do this in numerical order. So I have 1, 2, 3, 4, and 5. And then I close it off with my curly bracket. So same thing for my range. I'm going to list my y values. What are the different y values I have? 11, 12, and 13. I only have to write the 13 once. It's just showing that it appears sometimes. So, like I said, we always want to make sure our list for domain and range is in order from least to greatest. And then we only write down each number once, even if they repeat. So the next thing we're going to talk about is continuous and discrete. When a function is continuous, our domain is all real numbers. So any possible value of x can be my domain. And this is written with an R with a double line. Yeah, it's an R with an extra line. Okay. So, all real numbers means that the graph or function keeps going in the x direction. So it's going to go right and left forever. So I'm going to draw us two examples. Here's an example, and then here's another one. So our graphs are either lines or curves. So think connected with arrows at the end. So the next thing I have is when a function is discrete. The domain is whole numbers or integers. So think specific. Only what is needed. So kind of like when we were talking about our table of values up above, those are discrete functions. Discretes are also known as non-continuous. So I can have just a bunch of like random points, or I can have points that look like they make a line. So these ones are a series of points that are not connected. So my next example, I need to decide if the graphs are discrete or continuous, and then state their domain or range. So, this one, discrete or continuous? Okay. And then, so this one I'm going to write my domain just like we were doing on our first few examples. So I have my first curly bracket. What are my x values here? 1, 2, 4, and 5. So I only want the x values from points. What are my y values?
1, 2, and 5.
There's also 0. There's no 3. Is that a curly bracket you're looking at? Okay. So on the next graph, is this one discrete or continuous?
Continuous.
And then my domain here is going to be the phrase all real numbers because it goes left and right forever. For my range, is it ever going to go below 0? No, my arrows are pointing up. So I'm going to do y is greater than or equal to 0. So the last thing we're going to talk about is a situation with domain and range. So a function can model each situation. What is a reasonable domain and range for each function? So this first situation is a hose fills a 10,000 gallon swimming pool at a rate of 10 gallons per minute. So my reasonable domain is going to be 0 minutes to total time to fill. And then my range is, I can have an empty pool, or I can have a full pool. So it's 0 to 10,000 gallons. What? So, at 0 minutes, the pool should have 0 gallons. I think so too. After 1,000 minutes, the pool will be full. Which is a total of 10,000 gallons. Okay, so is this situation continuous or discrete? How am I filling the pool? With buckets where I just keep... Yeah, it's continuous. It's a hose that doesn't stop until I turn it off. Okay, then my next situation says a restaurant needs to order chairs for its table. One table can accommodate 4 chairs. So, my domain is going to be 0, so the number of tables. And my range is 0 to my number of chairs. Which should be a multiple of 4. Because I buy 4 at a time. Okay. So, a restaurant can have 0 tables with 0 chairs. But every table needs 4 chairs. So is this one continuous or discrete? Yeah, because I can't buy part of a chair.